on mastering, there was like a question where it says like if something's pushed down or to the left, does that affect how we would solve this?
If something pushed down or,
I think it was like
It was pushed
down
up
to the
pushed up to the right. It was the two boxes on the wall.
oh. Okay, and which way was the friction acting on it? Is it that one?
Yeah.
I think I'm talking about a different one.
Okay.
I think I'm talking about 10, but I don't even know if I drew it right. I know it's saying like 18 down and then 24 to the east.
Okay. And, all right, so the magnitude of the total force, it's very similar to that, except I just had a different direction. In that one, it was 24 newtons this way and 18 newtons this way.
If I did that right, yes.
Okay.
I hope I did.
So if I'm asking if I just said what's the force with a vector symbol like that, then I can get away with, I want to make I hat to the right and J hat, I could just make down. In which case, 24 newtons I hat plus 18 newtons J hat, because I said J hat is down. So that's the force. If I said what's the magnitude, which I think is what I actually asked, then Pythagorean theorem. So I have 18 down, I have 24 this way. My resultant is a vector from here to here. And the magnitude is just whatever that is.
I'm sorry.
So,
Just how would you phrase that question to get that answer?
What is the magnitude of the total force?
if, I did that math problem, but am I gonna get points off if I didn't put, while I was doing the math part, if I didn't put Newton for next?
No, you don't need units. You need
Okay.
units in the end. You don't have to keep track of units throughout.
Okay.
It's a huge clutter if you keep track of units throughout, unless you are dealing with just some bizarre units.
Okay.
In which case, then I recommend keeping track. But if you're sticking with the international standards, then I wouldn't waste time until at the end. If you're using the nice units, force in the end will be in newtons. Distance, displacement will be in meters. Speed, velocity, meters per second, and so on. Genesis, you had a question?
So it says that the 18 is acting north. Wouldn't it be?
Oh, did it? Okay.
Yeah. You would want it.
So acting north, so it would be going this way.
Okay, okay.
Hey,
It's,
unless I wanted to find north that way. The big thing is they're perpendicular to each other. So if that's the case and I kept this the same, then that would be negative 18 newtons J hat. If I still said J hat was positive J.
but you didn't say positive.
In which case, that would change into 18 going this way, 24 going that way. It doesn't change the magnitude of the resultant. It changes the angle, but it doesn't change the magnitude. Jason?
So to build off that, would that change since we know the magnitude of the, hang on, let me think of what here. 10B, would the maximum magnitude of force acting on the box be one of the 24?
No, what I'm looking for there is if I could point these arrows in any direction I want, what's the maximum total force I can have acting on the box?
Would it be the sum of 24 and 18?
Yeah.
And then,
The minimum.
again, follow up to that, the minimum, would that just be subtraction of the two?
Yeah, they're pointing opposite each other.
Okay.
So the maximum force would be 42. Or would you do
That's right.
Okay.
Please don't forget units in the answer.
Right. 42 minutes.
For those who haven't gotten it yet. But not.
Can you
I can-
explain? No, you said it right,
Okay.
but I didn't know if you were looking at me.
Oh.
My bad. But can you explain again why the 18 is negative?
Alright. It was I was told that it was pointing northwards, going with the classic map direction, north is up. Just because I've been brainwashed that way. If I still said J hat was down, positive J hat was downwards, and this is going up, it's in the negative J hat direction. That's why the minus on there. It just says, the minus says opposite the direction of J hat. J hat's this way, it's going that way, it's opposite direction.
So if we drew it the regular way, it would just be positive.
Yes.
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 So it depends how we draw J hat and
Yes.
Okay.
Or it depends what you tell us in the word problem,
Yeah,
because I don't remember J had in the word.
well, the magnitude is not gonna change regardless of whether it's plus or minus, because when you do Pythagorean theorem and you square it,
Yeah.
the
it's
minus
gonna be
signs go
same,
away.
Yeah, that's true. And then just to confirm, for the last question, the pulleys are ideal,
Yes.
okay? It doesn't seem. What?
I heard none of that, so
Oh, it
I'm
doesn't
assuming I
mean-
don't need to comment.
No. Doesn't mean I'll remember, but.
It turns out in that particular problem, because the rope, I didn't say it was ideal, but I gave it all the
Yeah,
characteristics.
of an ideal rope.
So the only thing that would make the pulley turn would be if the rope had friction.
Okay.
And if the rope is frictionless, the pulley's not gonna turn.
Okay,
The only thing that would really matter if the pulley had mass is if the pulley were a separate object. But I think I made the pulley part of the ground,
in part of this.
part of the ground and the ceiling.
Yes.
And so it's not gonna have a separate weight anyway.
Okay,
So W sub C for the, would count for the ceiling and anything attached to it.
yeah. And then the flower in the vase, you would count as one object.
I thought I had yes, I think I did have the flower in the vase as one object.
Okay,
Whatever I did in the drawing.
yeah, the flower's in the vase,
Yeah.
the drawing, but
Yeah.
I didn't know if you wanted that.
No, I drew the picture.
Oh, yeah, you
so
drew it
that it would,
together.
so you don't have to think about, all right, what's part of what.
Okay. That's right.
That was the
Thank
intent.
you. Huh?
That was the intent,
Okay, good.
because it was a nightmare before I started doing that. Other questions? Seemed like you had another question, Yvette, about a different problem, or did we get that?
It was
Oh, the pulley?
the pulley, but I think my other question would give away the answer.
Okay.
I think I just have to suck it up if I get it wrong.
I will leave that up to you.
Well, I mean, if you wanna give it, it's 19, I just wanna kinda understand, you talk about the quantity and construct, quantity type.
Oh, okay, which one, scale or vector, and
Yeah,
neither and either?
yeah.
All right, so
Either,
inertia is a tendency of an object to keep doing whatever it's doing.
yeah.
They had to come up with a word for it, so,
I'm more worried about force than inertia. I think I have inertia right.
I can't remember what you put down. I saw the number, but I don't remember what
Okay.
the number was.
I put neither for inertia.
That neither or either?
Neither, and,
Yeah, you're right,
okay.
because it's not a quantity. It's,
Yeah, it's.
we have a
zero.
quantity associated with it that's mass, but inertia in itself is just a property, it's not a.
It's a concept.
Yeah. Force is an example. Force is one of those key words, is a vector. Force is a vector.
Okay,
If I wanted just the magnitude, then I would need to say, what's the magnitude, the size of
okay.
the force?
But force in itself is just a.
Yeah, just like displacement is a vector, and so on.
So magnitude only is a scalar, right?
Yes.
So you would say, what is the scalar, or?
Generally, what's the magnitude of the displacement, what's the magnitude of the force?
Okay, magnitude is a scalar.
If I say, potentially, I don't think I've done this, but potentially I could say how much force. That's too vague. I should stick to the language magnitude of. Chase?
The push-up questions give me headaches. Yeah.
You didn't pull out a scale and, sorry.
Well, I thought about it. I genuinely thought about it, but I think I get that wrong too.
I don't do the scale of the elevator, no problem with you going, that wasn't in the master set.
There was an elevator, I don't remember if there was a scale one.
I don't
There was a
remember.
scale one
There was a scale one, not an elevator.
and an elevator one.
But not combined. Okay, I did that for the other groups. That was one I actually took a scale into an elevator just to make sure that.
Oh, stop.
Didn't film it though, that was too bad. All right. Because that's exciting video. All right. So, this is a person doing push-ups. So the first thing I'm gonna do is I'm gonna draw a representation of this problem. And they're on a scale? Or they're just pushing on the ground?
They're just pushing on the ground.
All right, so there's my picture of the person. The person is going up and down. And so if they start out at that position, they're starting out at rest, and then they move till they reach a maximum height, and then they come back down. They stop at the maximum height, they stop at the minimum height. Okay, so if you're starting here at rest, and you push up, you're gonna speed up.
Right.
So it starts out, acceleration is upwards, the velocity is upwards, you're starting out. Then you reach some point where you gotta slow down, because if you don't slow down, you're not gonna stop at the other end. So at some point, you're still going upwards, but you're slowing down. So this is still in the upward motion. Then you reach that point, you're at maximum speed, and then you start coming back down. So your velocity is down, so that's at rest. Then you come down, since you're at rest and start moving, you speed up. So your velocity is down, you're speeding up, so acceleration is also in the same direction. And then, at some point, if you kept speeding up, you're gonna smash into the floor. Most people don't. So, in the last bit, you're still going downwards, but you're slowing down, so acceleration is up. And then you stop again. And repeat and so repeat. So, the question was, at what point when you are,
While she is moving upwards and slowing down, she pushes on the floor with 240 pounds of force. During this moment, the floor pushes her with blank.
all right. If we look at the force diagram, usually get past these. Hopefully that's not too disturbing. So if we do the force diagram, these are the two objects. Is the grid disturbing anyone? Okay. Just, all right. Force diagram, what can we get rid of?
Friction.
Which one?
Friction.
All right.
Tension. Other.
Other.
That's it.
Yeah, it's basically box on ground.
Yeah.
All right, weight is acting which way on the person?
Down, and then up from the ground.
Okay, what about normal force?
Person up.
Person up. And then ground is down.
So it's asking you to compare the force the person exerts on the ground.
Yeah.
I think, do I say through direct contact? Did I put that parenthetically in?
She
Yeah.
pushes on the floor.
Okay, so this is the force she's pushing on the floor with. compare that to the force that the ground pushes on her.
Yes.
Well, I have two forces acting on her, which one is the ground pushing on her?
Wouldn't that handle?
Why? The same.
The same, it's the same.
Okay, so not,
Do you take into consideration your weight at all or anything like that?
the question is asking you to compare the force she exerts on the ground with the force the ground exerts on her, pushes on her.
Okay, yeah.
By Newton's third law, they better be the same magnitude. Or one of the fundamental foundations of this course is completely wrong.
Otherwise she probably
Yeah. You have objects accelerate themselves.
And then can we do the next one as well?
And the next one is comparing,
The
Well, I
earth
guess
pole.
it's weight.
okay, the gravitational pull,
Yeah,
and,
we're not given the mass or the weight,
okay, but comparing the gravitational pull and what?
the force,
It's the
the
same,
240
it's the
force.
same problem.
Same, well, it's a question of what we're comparing, so this time, this is the gravitational pull on her,
Mhm.
compared to, I assume, the normal force?
The 240 pounds of
It's push,
force.
yeah, pushes on the floor with 240 pounds of force,
Okay.
and then the force with which the earth pulls on him is.
So that's 240 pounds,
Yeah.
so that's 240 pounds.
So it'll be the same.
So this is the gravitational force that the earth exerts on her. This is the force that the ground exerts on her. So now we get into, I have two forces acting on them. I'm just gonna say up is positive, because why not?
Mhm.
So we'll make up positive. So my forces, I have 240 minus the weight
Mhm.
is equal to her mass times acceleration.
Mhm.
If acceleration is positive, then my weight is less than 240. The masses are positive, the mass is gonna be positive. They're, especially in classical physics, no such thing as negative mass.
Yeah.
So if acceleration is positive, weight has to be less than 240.
But we're not, are we given? Okay,
Well, we have the situation here,
we're not given the weight, we're not given the acceleration.
but acceleration is positive in this phase when she was starting from rest, moving up, speeding up. Acceleration is positive here when she is at the end of it, when she's coming down and slowing down.
Okay,
So those are the places where acceleration is positive. If acceleration is negative, then weight has to be more than 240,
yeah,
Like she was just a drop.
which would happen,
on the opposite, yeah.
and I forget what the situation was that I asked you to pick.
You asked us, based on the information, the force with the earth pulls through the gravitational force on him is,
When? Did I state that in the
Well,
previous
he's
problem?
moving upwards and slowing down.
Moving upwards and slowing down. So moving upwards,
okay,
slowing down, they're opposites. So the problem is asking this part right here. So up is positive, acceleration is negative in that region. If you're moving up and slowing down, if you're slowing down, acceleration and velocity, opposite signs.
Mhm.
So if she's moving up and slowing down, acceleration has to be down. Which according to that would make it negative. If you need a more specific number, you can make up a mass.
yeah.
How about, well,
No,
it's
no, I
240
just need
pounds,
to-
that's,
I just need to memorize our barn.
yes, better verb.
Can you re-explain, so like, I get the part where you say moving upwards, slowing down that portion, but can you explain the others?
If she's coming down? All right, if she is speeding up, acceleration and velocity are in the same direction. In other words, the net force is in the direction of movement. So at the peak, so she's at arms at max, and then starts dropping. So velocity is 0, velocity is not 0, I just sped up. So as I'm falling, my velocity, the downward force must exceed the upward force. Now as I get closer, I start to stop myself. So as I get closer, I have to push with more than my weight in order to slow myself down. If I didn't, my face would smack into the table. And I reserve that for off camera. So as you start to slow down, I was still moving down, but as I slowed down, my acceleration have to be the opposite direction, so my acceleration is pointing upwards. Which means the upward force is bigger than the downward force. Other questions or continued questions that I haven't quite answered?
I got confused on the number 11, where it talks about the minimum hourly work on earth, and the rate of
Right. All right, what's the relationship between weight and mass?
Weight has to do with the gravitational pull,
Okay,
so it can change, whereas mass does not change.
that's a key point. And mathematically, what's the relationship?
Weight equals mass times gravity.
Acceleration due to gravity.
There we go. If you just said mass times gravity, you left a few words out. All right. W equals mg. Which most of you should be familiar with, given that last slide. So if the weight is 21 newtons, the book was 21 newtons, is mass times the acceleration due to gravity. This was book on Earth.